Welcome to Minak Online tutorial. Before us is this trigonometric identity function or equation that says prove that the square root of 1 plus cos theta minus 1 minus all over 1 minus cos theta plus the square root of 1 minus cos theta all over 1 plus cos theta equals 2 cosec theta. Alright, first of all, let us resolve each of these trigonometric function. So here we have, take note that this, when we have, according to the rule of sword, that a all over b is the same thing as saying the square root of a all over the square root of what? B, right? And this case, we can also rationalize by saying multiplying both the numerator and the denominator by the denominator. And this is for this case. Now a case whereby you have the root of a all over 1 minus the root of b. In this case now we're going to rationalize also, but in this case here we are multiplying both the numerator and the denominator by the conjugate of the denominator, and the conjugate of the denominator is 1 plus the square root of b. Square root of b. So the conjugate of 1 minus square root of b is 1 plus square root of b. And if the case is, for example, we have let me say this is minus, okay, plus minus, so the conjugate here will now be minus plus, here also be minus plus. Okay, all right, now let us resolve this. So here we have the square root of 1 plus cos theta all over the square root of 1 minus cos theta. Now to rationalize here, we have 1 plus cos theta all over the square root of 1 plus cos theta. Okay, now let us also recall that the case whereby you have the square root of a times the square root of a will give us what? The square root of a raised to the power of 2, which will give us what? A, right? Now in other simple term, we can say the square root of 2 times the square root of 2 will give us the square root of 4, which will give us what? 2. So it implies that the square root of a number times the square root of the same number will just give you the exact value of that number. So here, so for the numerator here, we have 1 plus cos theta following this rule. Then all over here you will now have the square root of into 1 minus cos theta into 1 plus cos theta, right? Okay, now for us to resolve this now, this will now be 1 plus cos theta all over the square root 1 times 1 will give us 1. Now 1 times positive cos theta will give us plus cos theta. Now negative cos theta times 1 will give us negative cos theta, and negative cos theta times cos theta will give us what? Minus cos theta square. And the reason is minus times plus will give us what? Minus. So this will eliminate this, so we are left with 1 plus cos theta all over the square root of 1 minus cos square theta. Now let us also recall from the trigonometric identity that sine theta square plus cos theta square will give us what? 1. So, and if you are to make sine square theta the formula here, you have sine square theta equals 1 minus cos square theta. And since this is true, definitely we can say that 1 minus cos square theta will give us what? Sine. So to this side of the equation, the first side, we have 1 plus cos theta all over the square root of sine square theta. and the square root of sine square theta will give us what? Theta. I mean sine square. I mean sine theta rather. Here you have 1 plus cos theta all over sine theta. Alright, now this is the solution to this. Now let us now resolve this. Now take note. So here we have 1 plus cos theta all over sine theta. Alright, now let's take note of that. So for this other side of the left hand side, we have the square root of 1 cos theta now all over the square root of 1 plus cos theta. Now what we did at the other when we're resolving this to rationalize, so this time around this is 1 minus cos square theta, which is the conjugate of the denominator. So here you have 1 minus cos theta. Now since this and this are the same, so it implies that 1 minus cos theta for the numerator, and for the denominator this is saying, let me just resolve it again. So here you have 1 times 1 will give us 1. 1 times negative cos theta minus cos theta, then plus cos theta times 1 will give us plus cos theta, then plus cos theta times minus cos theta will give us minus cos theta square. Okay, we can now eliminate this, so we are left with 1 minus cos theta, then all over the square root of 1 minus square theta. Alright, say the same thing with what we did initially. Okay, so this one will also give us 1 minus cos square theta all over, here you will now give us what? The square root of what? Sine square theta, which will give us 1 minus cos square theta all over sine theta. Okay, now this solution here is the solution to this. Alright, so let us now bring this and this together as regards to the solution to these two. So here you have 1 plus cos theta all over sine theta, then plus 1 minus cos theta all over sine theta. Alright, to this point now, let us now add them together. Now take note that according to algebraic fraction, if you have a plus b now plus c over b, now here since they are having the same denominator, here you have a plus c over what? B. Now if I have to follow that rule here, so here you have 1 plus cos theta now plus 1 minus cos theta all over sine theta, right? And here, okay, so here we have equals, collecting like them here, 1 plus 1, then plus cos theta minus cos theta all over sine theta. Now this will eliminate this because plus a minus a will give us what? 0. So we are left with 1 plus 1, which is what? 2 all over what? Sine theta. And let us recall that this is something as saying 2 times 1 over sine theta, and 1 over sine theta is 2 times cosec theta, which is something as saying 2 cosec theta. Proved. Alright, that's the final solution. And if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and chemistry. Thank you and God bless you.